January 17th, 1945. Bastogne, Belgium. The fog came in like a thief just before dawn, swallowing the artillery positions whole. Sergeant Theodore Kovacs stood beside his M115 8-inch howitzer, watching his breath crystallize in air so cold it burned. Around him, the 240th Field Artillery Battalion had dug into frozen earth that rang like iron under the shovel. Somewhere beyond the gray wall, 6 miles out, maybe 7, German armor was regrouping near the village of Howitzers. Intelligence said panzer divisions. Intelligence said hardened positions. Intelligence said the American counteroffensive depended on breaking them. But Kovacs couldn't see 50 yards through the soup. The mathematics of artillery had always been elegant in its precision. Elevation angle, powder charge, wind speed, barometric pressure. Variables fed into firing tables that turned steel into surgical instruments. American gunners prided themselves on accuracy measured in meters, not miles. They could drop a 200-pound high-explosive shell into a target circle small enough to matter. But all of that assumed one fundamental thing. You could see what you were shooting at. You could observe the fall of shot, call corrections, walk your fire onto target like a man feeling his way across a dark room. The fog that morning made darkness absolute. Across the European theater, artillery units faced the same equation. The winter of 1944-45 had brought weather that defied every meteorological prediction, fog banks that lasted days, cloud ceilings that grounded spotter planes and turned observation posts into blind caves. The German defenders understood this gift. They moved under cover of gray, repositioned their guns, fortified their lines. American fire missions that should have taken minutes stretched into hours of guesswork. Shells landed in empty fields. Batteries fired pattern barrages, saturating entire grid squares with explosives, hoping some percentage would find steel instead of mud. The waste was staggering. In the Ardennes, artillery battalions were burning through their daily ammunition allocation by noon, achieving results that pre-war doctrine would have called criminal negligence. Battery commanders filed reports describing area neutralization because they couldn't honestly claim to have hit anything specific. Forward observers, those men who lived in the most exposed positions to guide the guns, found themselves useless, expensive binoculars pressed against faces, seeing nothing but white. Kovacs had been a mathematics teacher before the war. Public school in Cleveland, algebra and geometry to kids who mostly didn't care. He'd enlisted in '42 with the assumption that the Army would waste his education on something like inventory management. Instead, they'd looked at his transcripts and put him through fire direction school at Fort Sill, where they taught the geometry of murder, parabolic trajectories, mill-angle calculations, the way you could translate three-dimensional space into numbers, and numbers into explosions that landed exactly where you wanted them. He'd loved the precision of it, loved that war, for all its chaos, could be reduced to mathematical certainty, until the fog made mathematics meaningless. The men expected technology to solve it. That was the American way, after all. The United States had entered the war as an industrial giant, turning automotive factories into tank foundries, aircraft plants into B-17 assembly lines. American soldiers carried that confidence like extra rations. When something broke, you fixed it. When something didn't work, you invented something that did. The 50 caliber machine gun, the proximity fuse, the DUKW amphibious truck, solutions engineered by men in lab coats, delivered to men in foxholes. So when the fog persisted, the expectation was clear. Someone would develop better radar, improved radio direction finding, maybe some kind of infrared observation system. The solution would come from above, from the technical branches, from men with protractors and slide rules working in heated Quonset huts behind the lines. Kovacs knew better. He'd seen enough of the Army to understand that official solutions took time, requisitions, testing, distribution through a supply chain already strained to breaking. Whatever was going to save them wouldn't arrive in a technical manual. It would come from necessity. The stupid part came third. That's what Kovacs would tell people later, when the war was memory and the story had been sanded down to anecdote. The stupid part came after the observation, after the mathematics, after the moment when everything clicked into place with the inevitability of an equation solving itself. The observation happened on the morning of January 18th. Kovacs was running checks on the Howitzers' recoil mechanism, the hydraulic cylinder that kept 16,000 pounds of steel from leaping backward like a startled horse. The gun had fired 47 rounds the previous day, most of them blind shots into the fog, and the mechanism was starting to leak fluid. He was on his back in frozen mud, wrench in hand, when he heard it. Not the sound itself. The sound had been there all along, part of the background noise of war that you stopped noticing after a few weeks. What he heard was the change in the sound. The whistle of an incoming German shell, rising in pitch as it approached, then falling as it passed overhead. Doppler effect, they'd called it in college. The compression and expansion of sound waves as the source moved relative to the observer. Kovacs rolled out from under the gun and stood listening. Another German shell came in, this one closer. He could track it by ear. Rising pitch, approaching, falling away. It landed somewhere in the rear area. A crump of sound followed by a geyser of dirt and smoke that the fog swallowed almost immediately. But he'd tracked it. Without seeing it, using nothing but sound, he'd known where it was going. The mathematics came next, and it came fast. If you could hear the direction of sound, you could measure it. If you could measure it from multiple positions simultaneously, you could triangulate the source. And if you could triangulate the source of an enemy gun, you could calculate where to aim your own gun in response. It wasn't a new idea. Artillery had used flash ranging and sound ranging since World War I, specialized units with seismographic equipment and synchronized stopwatches. But those systems required setup time, calibration, specific geometric arrangements of listening posts. They were precision instruments for static warfare, for trenches that didn't move, and front lines measured in yards. Kovacs needed something faster. Something stupid simple. Something that could work with what he had. He had string. Literally string. Communication wire, to be exact. The spooled copper wire that Signal Corps men strung between positions for field telephones. Thousands of yards of it. Cheap and abundant. The infrastructure of American military communication. Kovacs drew a diagram in the mud with a stick, working through the geometry. 3 listening posts arranged in a triangle, each post connected to a central point by wire of exactly the same length. When an enemy gun fired, 3 men would hear it at 3 different times. The differences in those times would tell you the direction and distance to the source, unless you could make all 3 men hear it at exactly the same time. That was the string trick. Kovacs cut 3 lengths of wire, each exactly 500 yards long. He measured them by pacing, counting steps, stretching the wire taut between stakes driven into frozen ground. He set up 3 listening posts in a triangle, each manned by a soldier with a field telephone headset. But instead of connecting the headsets to a telephone exchange, he connected them to each other through the central point where he stood. And he didn't connect them electrically. He connected them mechanically. He tied all 3 wires to a single wooden board. When a sound wave hit listening, post 1, that soldier would tug on his wire. The tug would move the board at the central point. The movement would travel down the other 2 wires to posts 2 and 3. If the sound wave hit all three posts at the same time, if the source was directly in line with their geometric arrangement, all three tugs would arrive at the board simultaneously. If the sound wave hit them at different times, the board would move in a sequence, jerking first one direction, then another. By watching which wire tugged first, Kovacs could determine the direction of the sound source. By measuring how far apart the tugs were, he could estimate distance. It was primitive. It was inelegant. It required three men doing nothing but listening with their hands on copper wire, like telegraph operators waiting for a message spelled out in violence. But it worked. The first test came that afternoon. German 150mm guns had been harassing the American positions since noon, firing from somewhere north of Howitzers. The shells came in at irregular intervals, enough to keep everyone nervous, not enough to suggest a major bombardment. Kovacs set up his string triangle and waited. When the next German gun fired, all three listening posts tugged their wires within a half second of each other. The board at the central point jerked northeast. Kovacs had his direction. He plotted it on a map, drew a line from his position outward, and cross-referenced it with intelligence reports of known German artillery positions. Two candidates emerged. He picked the one closer to the tree line. German doctrine favored concealment, and calculated firing data for his howitzer. 6 miles. Elevation angle 42 degrees. Powder charge number 7. He ordered one round fired. 90 seconds later, the time it took for a 200-pound shell to fly 6 miles and gravity to pull it back to Earth, the German gun went silent. It stayed silent for the rest of the day. Word spread the way useful things spread in armies, laterally, soldier to soldier, bypassing official channels entirely. By January 20th, 3 other batteries in the 240th had built string triangles. By January 23rd, artillery units in adjacent divisions were asking for instructions. No technical manual, no formal training program, just men teaching men. Diagrams sketched in notebook margins, the technique passed along like a folk remedy that actually worked. The official name, when it finally got one, was differential sound ranging using mechanical tension indication. The soldiers called it Kovacs wire. Some called it the string trick. A few, with the dark humor endemic to men who lived surrounded by explosives, called it the world's cheapest radar. It violated every principle of modern military technology. It had no electronic components, no precision engineering, no scientific pedigree. It was 3 lengths of wire tied to a board, operated by men using nothing more sophisticated than their own hearing and sense of touch. It looked like something a child might build as a science fair project. But in the fog, when radar couldn't penetrate and spotters couldn't see, it gave American artillery what it needed most: targets. The Germans never understood what had changed. Their own artillery doctrine, inherited from decades of Prussian military tradition, emphasized mobility and concealment. Fire a mission, displace, fire again from a new position. The fog should have made them invisible, should have given them the same advantage it gave their infiltration troops in the Ardennes. Instead, they found themselves under accurate counter-battery fire within minutes of firing their own guns. Positions they'd used for days without detection suddenly attracted American shells with uncanny precision. Captured German artillery officers, interrogated in the weeks after Bastogne, expressed genuine confusion. They knew American artillery was good. Everyone knew that, had known it since North Africa. American forward observers were aggressive. American fire direction was fast. American ammunition supply was bottomless. But this was different. This was American guns shooting blind through fog and hitting targets they couldn't possibly see. Some German officers speculated about new radar systems. Others suggested infiltrated spotters. Allied agents somehow positioned behind German lines. A few, perhaps closer to the truth than they realized, wondered if the Americans had developed some kind of advanced sound-ranging technology, something beyond what the Germans themselves had experimented with in the Great War. They never guessed it was 3 men holding copper wire. The symbolic weight of it mattered more than the technique itself. That's what Kovacs understood later, after the war, after he'd gone back to teaching mathematics to disinterested teenagers in Cleveland. The string trick worked because it was improvised, because it used materials at hand, because it solved a problem through cleverness rather than industrial might. But what it represented was something larger. American abundance. Yes, the copper wire existed because American industry produced it by the mile, because American logistics could deliver it to frontline positions, because American military doctrine assumed communication infrastructure as a baseline. But more than that, it represented a kind of intellectual democracy. The solution hadn't come from technical specialists or scientific laboratories. It had come from a sergeant who used to teach algebra, working with the materials he had, drawing diagrams in frozen mud. The German military tradition emphasized expertise and hierarchy. The right solution came from the right people, trained specialists, educated officers, men whose authority derived from institutional position. American military culture, for all its own hierarchies and regulations, carried a different assumption: that good ideas could come from anywhere, that a sergeant might know something a colonel didn't, that the man closest to the problem might have the clearest view of the solution. Kovacs wasn't supposed to invent anything. His job was to maintain the howitzer, calculate firing data, follow the procedures outlined in the technical manuals. But when those procedures failed, when the technology couldn't solve the problem, he'd improvised something new out of the materials at hand and the mathematics he'd carried in his head since college. And the Army had let him, had adopted his solution, spread it laterally, incorporated it into operations without waiting for formal approval from technical branches or ordnance departments. That flexibility, that willingness to use whatever worked regardless of its pedigree, was its own kind of weapon. By February 1945, the fog had lifted. Spring came late to the Ardennes, but it came, eventually, bringing clear skies and visibility measured in miles instead of yards. Spotter planes flew again. Forward observers could see their targets. The string triangles were dismantled, the copper wire respooled and sent back into general communication inventory. The 240th Field Artillery Battalion pushed east toward the Rhine, then across it, then into Germany itself. Kovacs stayed with his howitzer until April, when a German 88mm shell landed close enough to blow his eardrums and send him to a field hospital with perforation injuries. They evacuated him to Paris, then England, then home. He was in New York when Germany surrendered, standing on a dock and processing paperwork, still half deaf from the concussion. He never saw the official after-action reports, never knew if the string trick made it into doctrine or training manuals. By the time he got home, it didn't seem to matter. The war was over. The questions that had occupied him, how to hit targets you couldn't see, how to turn sound into location, how to make copper wire and geometry into a targeting system, had become historical curiosities, problems that belonged to a moment in time that was already receding into memory. But the lesson stayed. Decades later, military historians would study the fog operations of January 1945 as examples of tactical adaptation under environmental constraints. They'd note the innovation in sound-ranging techniques, the lateral spread of field-developed solutions, the way American artillery maintained effectiveness despite meteorological conditions that should have neutralized it. Some would mention Kovacs by name. Most wouldn't. That was the nature of war. a million small innovations lost in the larger narrative of armies and nations. But the men who were there remembered. Not the technical details necessarily, not the exact geometry of the string triangle or the mathematics of sound propagation. They remembered the feeling of it. The fog closing in like a physical thing, cutting them off from the war beyond, making them blind and helpless. And then the solution, emerging not from headquarters, not from the technical branches, not from the arsenal of democracy's industrial might, but from one sergeant who'd been a teacher, drawing diagrams in frozen mud, solving the problem with materials scrounged from Signal Corps inventory and mathematics he'd learned teaching kids in Cleveland. They remembered that democracy wasn't just a system of government or an ideological position. It was a methodology. It was the assumption that solutions could come from anywhere, that authority didn't have a monopoly on intelligence, that 3 lengths of copper wire tied to a board could be just as sophisticated as any radar system if it solved the problem at hand. The Germans had better trained artillery crews, longer military tradition, tactical doctrine refined over centuries of European warfare. But when the fog came down and the old methods failed, their system couldn't adapt because adaptation required innovation from below, and their structure didn't permit that kind of flexibility. The Americans could adapt because their system assumed that flexibility as a baseline, not because they were better soldiers or smarter tacticians, but because their culture, military and civilian both, carried the assumption that the man holding the wire might know something worth listening to. The string itself became nothing. After the war, after the copper was respooled and redistributed, after the wooden boards were burned for firewood and the stakes pulled from frozen Belgian ground, nothing physical remained. No monument marked the spot where Kovacs had set up his first triangle. No museum displayed the wire itself. The technique didn't make it into popular histories of the war, didn't become one of those colorful anecdotes that journalists and filmmakers love to highlight. But in the cold calculus of artillery effectiveness, in the ratio of shells fired to targets destroyed, in the counter-battery success rates of American artillery units operating in fog during January and February 1945, the impact was measurable. German guns that should have operated with impunity found themselves under accurate fire. American infantry advancing under their own artillery umbrella faced less incoming fire, took fewer casualties, moved faster toward objectives. How many lives did 3 lengths of copper wire save? The question was unanswerable because the counterfactual was unknowable. But the Germans fell back, and the Americans advanced, and somewhere in that mathematics of momentum and morale, the string trick mattered. Not because it was sophisticated, because it worked. Not because it came from the top, because it came from the middle, from the space where necessity met knowledge, where the man who understood both the problem and the mathematics could draw a diagram in mud and solve what technology couldn't. That was the abundance America brought to war. Not just tanks and shells and aircraft, though it brought those in staggering numbers. It brought the assumption that intelligence was distributed, that solutions were collaborative, that a sergeant with chalk dust still under his fingernails might see something the experts missed. The fog lifted. It always did. Weather systems moved, fronts shifted. Spring came eventually even to Belgium in 1945. The immediate problem solved itself through meteorology, and the improvised solution faded into the category of things that had mattered once but didn't anymore. Except it did matter. It mattered because it demonstrated something essential about how democracies fight wars. Not through predetermined doctrine or rigid hierarchy, but through flexibility and adaptation. Not by demanding that the frontline soldier conform to the system, but by allowing the system to incorporate solutions that emerged from the front line. The string trick was stupid in the way that all elegant solutions are stupid, obvious in retrospect, inexplicable in the moment, impossible to imagine until someone draws the diagram and suddenly everyone understands. It worked because Kovacs understood both the mathematics and the materials, because the Army gave him space to experiment, because American logistics had spooled enough copper wire to let him waste 1,500 yards of it on a theory. Because abundance, real abundance, wasn't just material wealth. It was the abundance of possibility, the assumption that good ideas deserved testing regardless of their source, that the hierarchy could pause long enough to listen to the sergeant holding the wire. And in the fog, when nothing else worked, that assumption made all the difference between shells landing in empty fields and shells landing on target 6 miles away, hitting what they were aimed at even though no one could see what they were shooting at. Mathematics and copper wire, geometry and improvisation. The stupid string trick that turned sound into location, and location into fire, and fire into advantage. That was how wars were won, not just with industrial might or technological superiority, but with the willingness to let a teacher from Cleveland tie 3 wires to a board and see if it worked. It did.